So this is the 30th session on relative velocity. So this is in continuation of the 29th video. So in 29th video, a single question on relative velocity one-dimensional collision problem was taken up. So in this video also a similar type of problem will be discussed. Okay, just for the sake of practice, so that students, if they practice more and more, then they'll develop more speed. They will solve the problem much more easily and much more faster. So in this video also, the problem which will be discussed will be similar to that of the 29th session, previous video. Okay, so I'll write down the question again. P1 and P2 are two moving points. P1 and P2 are 2 points moving along the common line joining them. With constant respective accelerations P1 to a leftward and P2 for a rightward with respect to ground, G for ground. Okay, so initial acceleration of P1 is constant to a leftward, and for P2 it is for a rightward. Both are constant with respect to ground. Okay, so to a left and for a right. Okay, fine. Initial speeds of P1 and P2 with respect to ground is U1 and U2 respectively. At time 0, the initial separation between these 2 points is L. Between P1 and P2 is L. Three values is vector notation. Three values of U1 and U2 are given. First, P1 6U leftward and P2 6U rightward and U rightward. Part B, P1 U leftward and P2 5U leftward, and C, part C is P1 U rightward and P2 8U leftward. Acceleration values are 2 and 4, they are common for all three of them, A, B, C. In each of these cases, in each of A, B and C, find the minimum value of U so that P1 and P2 collide. This is the question. Okay, so this we have to solve again using the concept of relative velocity. Relative velocity concept has to be used for solving this problem. Fine. Now I'll grab it. Okay. So now again the acceleration values of P1 and P2 are common for all A, B, C and 3 of them. Okay. So how do we start it using relative velocity? Again, we solve the problem either as seen from P1 or as seen from P2. It's a matter of choice. So we solve it from the problem as seen from P1. So solved as seen from P1. Fine. Then what do we do? We find the relative acceleration of P2 with respect to P1 in ground frame, as we did in the previous video. So let A P2 P1 slash G, relative acceleration of P2 with respect to P1 in ground frame, that is just equal to A2G minus A1G equal to that is just equal to A2G plus vector sum of A2G and reverse of A1G minus A1G reverse of A1G. Now A2G is how much? A2G is 4A rightward. A2G is just equal to 4A rightward and vector sum of reverse of A1G. A1G is 2A left, so reverse of A1G is 2A right. Vector sum of 4A right and 2A right is nothing but 6A right. That is A relative, which is A relative say, which is a constant quantity. So this means that acceleration of P2 with respect to P1 is constant, 6A rightward. Acceleration of P2 with respect to P1 is constant, equal to 6A rightward. Alright. Acceleration of P2 with respect to P1 is 6A rightward. 6A rightward. So A relative, that is, say A relative, fine. So now one more thing. As seen from ground, P1 and P2 are moving along a straight line joining them. So this means as seen from P1 also, P2 will move along a straight line joining these 2 points. So since P2 and P1 are moving along line joining them with respect to G ground, implies that with respect to P1 also P2 moves along the same line. With respect to P1 also P2 moves along the straight line. So this means as seen from P1, P2 undergoes straight line motion with constant acceleration. With respect to P1, P2 moves along a straight line with constant acceleration. With constant acceleration equal to how much? 6A right. So this means 4 formulas for motion of point along straight line with constant acceleration: V barabar u plus at, d is equal to ut plus half at square, v square equal to u square plus 2ad, d barabar u plus v by 2 into t. They are valid in this case. So we apply the third formula. V relative square equal to u relative square plus 2a relative into d relative. This formula is going to be valid. V relative is again the relative speed between these 2 points at an arbitrary instant. U relative is the initial relative speed between these 2 points. A relative is the relative acceleration between these 2 points, magnitude. And D relative is the relative displacement of P2 with respect to P1 in ground frame in certain time interval. Fine. So this much part is common to all A, B, C, or all 3 of them. So this part will, till here it is common. Okay. Now what we have to do is that we have to find this U relative first. Okay. So 3 possible cases are given. I'll write it again here. So first case was that P1 is moving at a rightward speed of 6u initially, 6u rightward, and P2 is moving at initial rightward speed of u. Okay. So this case what do we do? We have to determine u relative. U relative is the relative velocity of P2 with initial relative velocity of P2 with respect to P1 in ground frame. That will be written as u P2 P1 slash g. That is from the theory of relative velocity between 2 points. It is u2g minus u1g. That is equal to u2g and reverse of u1g. Now u2g is 6u rightward. u2g is 6u rightward. And u1g is, this is not, sorry. So u2g is equal to u rightward. And u1g is 6u rightward. So minus u1g will be 6u leftward. vector sum of 6u leftward. So vector sum of u right and 6u left from parallelogram law of vector addition is 5u leftward. Okay. So initial relative velocity of P2 with respect to P1 is 5u left, and constant acceleration of P2 with respect to P1 is 6a right. Now one more thing, since A relative and U relative are in opposite direction, A relative and U relative are in opposite direction, implies that relative speed between P2 and P1 decreases as time passes by. As time passes by, relative speed of P2 with respect to P1 decreases. Okay, fine. So now I'll rub here, okay. So in first part of the question, this part, we have found that u relative is just equal to 5u left, and A relative is constant, that is same for all ABC, that is just equal to 6a rightward. So here just now, as I mentioned, V relative will go on decreasing as time passes by. So again two possible cases arise. This is P1, this is P2. It has constant rightward acceleration of 6a, and with respect to P1 it is moving leftward at a constant speed of 5u. So they are in opposite direction, which means as time passes by, relative speed of P2 with respect to P1 goes on decreasing. So one possibility is that P2 does not reach P1, but somewhere in middle only, somewhere before reaching P1 itself, relative speed of P2 with respect to P1 becomes 0. Suppose P2 comes here, and here V relative becomes 0, say. Now what happens if P2 comes to rest here with respect to P1, but still its relative acceleration is rightward, so it will again begin to move rightward. So there is no scope, no chance of any collision taking place. So for collision to take place, relative speed of P2 with respect to P1 should be more than 0, and P2 reaches P1. So this I'll write it again, as I have been doing in the previous video also. So for collision to take place, relative speed of P2 with respect to P1 must be more than 0 when P2 reaches P1. Fine. So this is the condition for collision. Now we apply that formula again. V relative square equal to U relative square plus 2A relative into D relative. Now U relative is how much, as we discussed just now? U relative was 7U leftward. So this is 7U left. Left side positive, right side negative. A relative is minus 6A, because relative acceleration of P2 with respect to P1 is 6A rightward. Left side is taken to be positive, so 6A minus. And D relative is the relative displacement of P2 with respect to P1 when P2 reaches P1. Now, since we are observing the problem as seen from P1, P1 is here, at same location. Time 0, at time 0 P2 is here, L distance away. And when P2 reaches here, then as seen from P1, P1 is at rest. So when P2 reaches here, then relative displacement of P2 with respect to P1 will be L left, that is again plus L. This V relative should be more than 0. So this quantity 49U square minus 12AL should exceed 0. U should be more than 12AL by 49. This is therefore the minimum value of U. Fine. So minimum value of U so that collision takes place is this much. If U is less than this quantity, there is no scope for any collision. If U is equal to this quantity, then what will happen? P1 just P2 just reaches P1 and then its relative speed becomes 0. So in this case also there will be no collision, but it's just a limiting case. But if you exceed this quantity, then collision is going to take place. So this is the required minimum value of u. Fine, alright. So part A has been discussed. Now we take the part B of this question. Part B also relative is same, 6 I rightward. So part B. I'll rub this one also. This one also I'll rub, okay. Part B. So part B, P1 initial speed of P1 is given to a u left. And initial speed of P2 is given to be 5u left. Again we have to find the minimum value of u so that collision takes place. Again we determine u relative as we did just now in part A. U relative is just u P2 P1g, that is just equal to u2g minus u1g, that is just equal to u2g plus minus of u1g, and u2g is 5u left and u1g is u left, so minus u1g, that is reverse of u1g, will be u right. So 5u left and u right from parallelogram law of vector addition, that will be 4u left. So this is u 4u left and A relative is 6u right. A relative is 6u right, alright. So this means that since u relative and A relative are in opposite direction, since u relative and A relative are in opposite direction, implies that relative speed between P1 and P2 decreases as time passes by. So again two possible cases arise. First case is this, P1 is here initially, P2 is here. P1 is there, always there, because we are observing a scene from P1. Now P2 is moving initially leftward with initial relative speed of 4u. As it is moving ahead towards P1, its relative speed with respect to P1 goes on decreasing. So one case is that P2 does not reach P1 and it's somewhere before only its relative speed vanishes. Then what will happen? Still, even if P2 comes here, where its relative speed becomes 0 with respect to P1, still its rightward acceleration with respect to P1 is 6u rightward. So it will be 6 rightward. So it will begin to move rightward again. So there is no chance of any collision. So again collision to take place. Relative speed of P2 with respect to P1 should be more than 0 when P2 reaches here. So for collision to take place, relative speed V relative of P2 with respect to P1 should be more than 0 when P2 reaches P1. So again, how to determine V relative? We use the third formula as we have been doing just now in part A also. V relative square equal to U relative square plus 2A relative into D relative. U relative is how much? 4U left. 4U whole square. A relative is minus 6A as we have been doing it. Sign left side plus, right side minus. D relative is the relative displacement of P2 with respect to P1 when P2 reaches P1. As seen from P1, P1 is at rest. Initially P1 is here, P2 is here, and P2 is moving towards it. So relative displacement of P2 with respect to P1 is simply L when P2 reaches here, because P1 is at fixed with respect to itself. So D relative is again plus L. So this is equal to 16U square minus 12AL. This should be more than 0. So U should be more than root under 12AL by 16. This is therefore the minimum value of U. This is the required answer to the part B of the question. Fine, alright. So part B also has been solved. This is the minimum value of U. Fine. Now we solve the part C. Part C of the question. Initial speed of P1 with respect to ground is u right. And initial speed of P2 with respect to ground is at u left. Again we have to find the same thing, minimum value of u so that collision takes place. To find the minimum value of u so that collision takes place, that we have to find out. Again we carried the same procedure. We first determine u relative velocity, initial relative velocity of P2 with respect to P1 in ground frame. That is just u2g minus u1g. That is just u2g and reverse of u1g. And u2g is how much? At u left. So u2g is at u left plus u1 reverse of u1g. u1g is u right. Reverse of u1g will be u left. So vector sum of these two from parallelogram law is 9u left. This is 9u left. And A relative is how much? That is same, which we found out first time during one time calculation. That is just 6a right. Now u relative and A relative are in opposite direction. U relative and A relative are in opposite direction, which means as time passes by, V relative decreases. So again two cases arise. First case is what? P1 is here at time 0, P2 is here at time 0. Initial separation is L. Initially with respect to P1, P2 is moving leftward with initial speed of 9u and a constant rightward acceleration of 6a. Alright. So it is moving in this side towards P1. Relative speed of P2 with respect to P1 goes on decreasing. One case is that P2 does not reach here before only its speed relative becomes 0. But still because of a relative it will move rightward. So there is no chance of P2 coming to P1 and hitting it. So no collision. Again collision to take place, V relative of P2 with respect to P1 should be more than 0 and P2 reaches P1. For collision to take place, V relative should be more than 0 when P2 reaches P1. Again to find V relative we will use the third formula for constant acceleration along straight line. V relative square equal to U relative square, U relative 9u. 9u whole square plus 2a relative. A relative is minus 6a. Left side positive, right side negative. Acceleration rightward to minus. Relative displacement of P2 with respect to P1 when P2 reaches P1. That is again L. Because with respect to P1, P1 is fixed. Initially P2 was at L distance away. So plus L. So this quantity should be more than 0. This means U81 U square more than 12AL. Okay. This means U should be more than root under 12AL by 81. This is therefore the minimum value of U. Alright. This is therefore the minimum value of what? U. This is the minimum value of U. So that collision will again take place. Fine. So this was the 30th video. This also has been fully discussed. Fine. Now we will take one more video. I will take in 31st session. In that I will discuss one more problem of this type for the sake of practice and familiarity. Alright. And then I will take some different types of relative velocity problem. First I will take up relative velocity shortest distance questions. Okay. That I will take up in 32nd video. In 31st video I will take a similar problem similar to this. And then I will take up 32. I will take up whatever just I said. Okay. Shortest distance problems. Fine. Alright. So I close this session just now here. Alright.